So when you were just a little tiny kid about this big, maybe in 3rd grade or something like that, people start telling you things. They start telling you things like this. They start telling you things like, oh, -1 times -1, that's equal to +1. But they never really tell you why, so I thought today I would try to find some answers. So who knows all the answers in the universe? Of course Google does. So I'm going to try to find out for us exactly why is -1 times -1 equal to 1. Right, simple question. What? No results? Did not match any documents? Well, maybe I just wrote it wrong. Maybe I should change this to a times. What? No results? No, it can't be it. Nobody knows this. Google knows more than all the knowledge in the universe. No, wait. Maybe I wrote it wrong. Maybe I should change it to this with parentheses like this. Oh, good. I've got, let me see. Those are thousands, hundreds of thousands. Those are millions. Well, I got trillion. I got 9.6 trillion documents in a little over half a second. Surely there's something here. Wait, no, that's not it. Why is 1 plus 1 plus 1 plus 1? That sounds a little crazy. Not that. Skip that. Oh, wait, let me, no, not that. Why 1 plus 1 is 2? No, that's not, doesn't, no. 1 plus 1 equals 0. I don't think so. No. What? Wait, maybe I just have to check the other pages. 911? No, what? No, what? Maybe I have to check the 10th page. What? Diabetes? No, what? No way. Maybe just Google is crazy. Maybe we should try something else like Bing. So we try on Bing. Why is -1 times -1 equal to 1? Yeah. What? No results found? What's up, Bing? I thought you knew everything. Psst. Maybe we gotta offer some cash money. Can somebody please explain to me why -1 times -1 is +1? Please find me an algebra book that explains this honestly. If there's millions, there's 9 trillion algebra books. I'll give you some cash here if you just help me figure out why exactly is -1 times -1 +1. Come on now, you can do it. Amazingly important day, an awesome day. Today we get to learn to multiply by negative numbers. And I don't just mean like learn, I mean like really learn, like Bugatti perfection learn. We're going to start off easy. We're going to learn to multiply by -1, and then we'll learn to multiply by other negatives. But I think that this is the key. If you can multiply by -1, the rest of it will be super easy. For example, we're going to try to multiply -1 times 5. But before we do that, let's organize our thoughts here. Here, as you will remember, last time we talked about things, we had already learned how to multiply these numbers. These are called natural numbers. And we already know how to multiply things like 2 times 3. Well, that's equal to 6 by the times table. We already knew how to do that. That's no problem. 1 times 3, 2 times 3, 3 times 5. All these, piece of cake. Done. Check. We also learned how to multiply by 0 last time. We had this very important thing called the zero multiplication theorem. 0 times 5, well, that's equal to 5 by 0 multiplication theorem. That we did last time. So check. We already know how to multiply by all those, the natural numbers and 0. That's called the whole numbers. What we'd like to do is maybe just extend it one more. Can we just learn to multiply by -1, and then of course eventually we'll learn to multiply by all of them. That's a good way to keeping our thoughts organized. We're doing this methodically, obsessively methodically, because this is the Bugatti of algebra classes. We don't do wishy-washy stuff here. We prove everything. Not because you're going to be a mathematician, but because you want some swagger in your walk. You want to be able to say, you know what, I went to 3rd grade and I learned to multiply by negative numbers, and then I really learned to multiply that when I went to DABS. Alright? So, talk is cheap. We say we start doing some multiplying, huh? By -1. So let's turn back the page here and see if we can say something about this. So there's many ways of doing this proof. I'll propose one here. So we could Let's go with red. No, you guys like red? Let's go with yellow. This is going to be yellow proof. So here's one way to do it. The hardest part for a lot of these proofs is the starting point. That's the whole thing. It's the most creative part here, because nobody knows where to start. I know that I got to end up with that is equal to 5. I know that's going to be the end, but I don't know where to begin. The problem is you have to begin with something that's true, that you already know is true. Or you have to begin with the left side and end with the right side. That's two approaches. Talk is cheap. Let's do it. Trouble is we don't know where to start. That's not a new trouble. That trouble has troubled humans for the entire history of troubleness. Think about Beethoven. Nobody told him that he should start like this. Da 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 da. Nobody knew he should start that way, but he did. That's what's beautiful about being a human and having that 3.5-pound brain that does amazing things. It's almost like divine inspiration. It comes out of nowhere. Dun, 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 dun. All right, here's your negative 1 or 0 times 5. I know what that is. That's equal to 0. Why? By the zero multiplication theorem. That's what we did last time. And then I'm going to do something amazingly clever. I mean, that was already clever, but wait, there's more cleverness coming. Because who knew that's where you should start? It doesn't look the same. But wait, so this will become negative 1 plus 1 times 5 is equal to 0. Why? Because negative 1 plus 1 is equal to 0. And we have a famous axiom for that. It's called additive inverses. That's why. And I can go on and I distribute this so that I get negative 1 times 5 plus 1 times 5 is equal to what? Is equal to 0, right? So all I did here is distribute this. This is times, and so what we did here is we took the 5 and distributed to that and distributed to that. That's justified by, of course, the famous distributive law. Okay? But wait, there's more. Now I can say, well, I do know how to multiply 1 times 5. That's equal to 5. The reason I know that is because multiplicative identity says nothing happens when you multiply by 1. 1 times 5 is still 5. It's beautiful, huh? You can almost see the end of it here. I'm going to subtract 5 from both sides, but we don't. There's no axiom like that. We're going to add a 5 killer on both sides. So negative 5. So I'll go with negative 1 times 5 plus 5 is equal to 0. And then I'll add something to both sides. I'll go with red here. I'll add a negative 5 to that side, and I'll add a negative 5 to that side. You don't really need parentheses here because there's only one term. So nothing would happen if you had parentheses. Here there's a couple terms. To keep things safe, I'll add parentheses. I'll justify this step. This is cancellation law of addition. It means add stuff to both sides. Okay? And then we're going to slide the parentheses over, and these are going to kill each other. So, let's do that. So negative 1 times 5 plus 5 plus negative 5. That's equal to 0 plus negative 5. That's called associative law of addition. The parentheses slide over. Now the 5 and the negative 5 are rather easy to do. We define negative 5 to be the killer of 5. So it will kill it. Nice killing of each other. 0 is equal to 0 plus negative 5. Those are additive inverses. But wait, there's more. 0 plus anything will give you the same thing. 0 plus anything. 0 is pretty harmless. It's the additive identity. So this will give you negative 1 times 5 is equal to negative 5 by additive identity. Yippee-ki-yay. See? That's a proof right there. That's money. Beautiful, huh? And the truth is, there's nothing special about these steps. I bet if I had started off with negative 1 times 13, I would have probably gotten a similar result, negative 13. If I had started off with negative 1 times 6, I would have gotten similar results, negative 6. These steps didn't really depend on the 5 that much. It could have been any other real number. Okay, the only thing here is we can add a negative 5 to both sides. So long as you can do these steps with these numbers, the result will be the same. And so we packaged them all into one package. One beautiful, amazing package that we shall call the minus theorem, which basically says if you have a negative 1 times any number n, well, you get negative n. Or said differently, the additive inverse of 1 times n is equal to the additive inverse of n. Or said differently, you can switch it around. You can look at it from right to left. It says if I have a negative 7, for example, I could always squeeze a 1 in there Or said differently, I can take out the negativeness from it as a factor and have it negative 1 times 7. That's the minus theorem. Money. What that does is that gets us to this point. Now take a look at our inventory here. These are the integers. We knew how to multiply those before. We learned this with the zero multiplication theorem, and we just learned how to multiply by negative 1. Negative 1 times any of these, like this. Negative 1 times 2, for example. This is negative 2. Or read that way, I can take the negative 2 and take out the negativeness into a factor. So we're good up to here, almost. We know how to multiply. What we'd like to do is take any one of these negatives at times any one of these positives, and maybe see how that goes. So we take a look at this example. Negative 2 times 5. How would you do that? Well, it's easy. That's why they pay me. Shoot, I would do this for free, even if they didn't pay me. So, but they do pay me insane amounts of money. So here we go. Negative 2 times 5. That's the same thing as negative 1 times 2 times 5. What? I know. What I just did here, this was the given. We started with this. And the negative 2, I split up. I took out the negativeness from it as a factor, as per the minus theorem, the one we just proved like 2 seconds ago. The minus theorem says I could do that. Now I can take this negative, this parentheses, and slide them over. 2 times 5. That would be Associative Law of Multiplication. It says you can slide parentheses over. Now, of course, that would be times table. 2 times 5, I know how to do that, times table. And now I have a negative 1 and a 10. We just learned, according to the minus theorem, how to multiply negative 1 times any number, any positive number like this. So this will be negative 10 by the minus theorem. Okay, or said differently, I glue back the negativeness into the number. That's beautiful. So beautiful, we should collect all these steps and take them into one theorem. And this one's called the negative times positive theorem, which tells you how to multiply any negative times any positive. It says that any negative times any positive will give you the negative version of the product. Said differently, if I have negative a times b, that would be equal to negative ab. Or even differently, negative 12 times 3 will give you negative 36, of course, and that's by negative times positive theorem. See? This is almost like the minus theorem, but the minus theorem was restricted to negative 1, multiplying by negative 1. This one's not restricted. Any negative, any positive. Money. I'm a B.